Before we continue on to exercise 15.3, we're just going to go back and look at exercise 15.2. Now, these are vertical dilations. These are the dilations that you are used to. You've seen these in year 11 before, in year 9 and 10, etc. It's where your constant is in front of the function. So it's like if you've got x squared, we've now got 2x squared. It makes it steeper, or 4x squared. That's what we looked at last lesson. So we just have to be very careful here with the language. You just need to listen very, very carefully. This dilates the curve vertically along the y-axis, so it stretches it up. So if we say along the y-axis, listening carefully, when I say it dilates the curve vertically along the y-axis, this is like this, for example. It may have looked like that, and now it looks like this. Okay, that's what I mean, dilates it vertically along the y-axis. It's stretching it along the y-axis. So, for example, if this was the point 1,1, it now might be the point 1,4 or something. So the y value got stretched up, got moved up. The y value got moved. So this might, the example of this might be y equals x squared, and this one's y equals 4x squared. Okay? So this is stretching vertically along the y-axis, or by a factor of k. So the k is the 4 in this case, so by a factor of 4, or we say it dilates the curve by a factor of 4 from the x-axis. So you either say along the y-axis is the same as saying from the x-axis. All right? See how it's been stretched from x, but it's being stretched along y. So along y is the same as from x. Now, like I said, what you're used to seeing is something like this, where you put the constant in front. It's like when you're doing straight lines, y equals x, you got y equals x, y equals 2x, 3x, 4x, it gets steeper. Y equals x squared, 2x squared is steeper, 3x squared, 4x squared is steeper. Okay? So that was the original type of stretching that you've seen, and that's stretched along the y-axis or from the x-axis. Or stretching from along the y-axis is the same as dilating from the x-axis or stretching from the x-axis. Okay? Now, what they're saying here is, with this first one, if k is greater than 0, so this is where your constant is in front of your function, the graph is stretched from the x-axis or along the y-axis. Okay, and if k is a fraction between 0 and 1, the graph is shrunk or compressed. That's where it goes wider. It's compressed from the x-axis, or it's compressed along the y-axis. So from one axis is the same as along the other. Okay, by that scale factor, by a factor of k. So now, are we okay? Now, like I said, the vertical dilation changes the y values of the function. All the transformations or the stretches that you've seen so far in year 11 were vertical dilations, okay? Where we put a number in front of your function, where we put a constant in front. It stretches it, it makes it narrower, all right? Now, this is where my little error is. Yes, so, for example, let's look here. We've got y equals x squared. Y equals 2x squared, we know is steeper, so it's been stretched from the, by a factor of 2 from the x-axis or along the y-axis. So you can say from the axis, x-axis, or it's stretched along the y-axis. Now, this is where the error is. So we say this one's now wider. There's y equals x squared in black. Y equals a half x squared. You know how I said it's been compressed? It has been compressed. I said compressed by a factor of 2. You don't say that. It's always just a half. It's always what the constant is. So compressed by a factor of half actually means the same as stretched by a factor of a half. You don't, so it's just, I would say it's been compressed and the factor is a half. The factor is just what's outside the front. It's the k, okay? So it's been compressed by a factor of a half. Can you fix that on your sheet? I had 2. It's compressed by a factor of a half from the x-axis. What does that mean? It's half, like, let's say if we look at this point up here, it was 2, 4, but now it's 2, 2. So the distance from the x-axis has halved for that particular value of x. Look, we had 2, 4 in the original function, and now it's 2, 2. So yes, this is along the y-axis. It's been, you can say stretched by a factor of a half, which means it's been compressed. Do you get it? If the scale factor is less than 1, it's actually compressed. So you'll see in some books it'll say stretched by a factor of a half. If you stretch by a factor of a half, you've actually made it smaller. If you stretch by a factor of 2, you're making it bigger. It's like scale factor. When you have one object and you make it into another object, if the scale factor is bigger than 1, it gets bigger. And if the scale factor is less than 1, it gets smaller. Okay, so we say stretched by a factor of half from the x-axis, but it's been compressed. It's been compressed, so if k is less than, if it's between 0 and 1, it's been compressed. Now you can also say that it's stretched by a factor of a half along the y-axis. Yes? Got it? Do is when it's being stretched upwards like that, the normal type that you're used to seeing, you must say from the x-axis because it makes a difference. So this is stretched by a factor of 2 from the x-axis. Okay? This one here, stretched by a factor of a half from the x-axis. It's whatever the constant is. Okay? From the x-axis or along the y-axis. They are the same. But what we're doing today is different. So it's really important to say from the x-axis for these ones. Now this is different. Guys, look at this one. What we had before was the constant out the front. Okay? That just makes it stretched from the x-axis or along the y. It stretches it up and down. But this one, the A is next to the X. You know when we looked at sideways shifts and whatever we were shifting sideways was next to the X? The A is next to the X. So this is no longer a vertical dilation. It's called a horizontal dilation. So can you put here that these are horizontal dilations? Can you see the difference between this and what we were just doing? The other one was y equals k times the function of x. This is y equals function of ax, where the a is in the bracket next to the x. Okay? Now, so for the curve y equals function of x, y equals function of ax stretches the curve horizontally this time, along the x-axis. Because the x-axis is here, so it stretches it that way. That's stretching horizontally. But by a scale factor of 1 on a. It's not by a scale factor of k like the other one, it's 1 on a. Okay? So if you stretch horizontally along the x-axis, it's said to dilate by a factor of 1 on a. So remember, along the x is the same as from the y. You got it? Along the x-axis is the same as saying from the y-axis. So you need to write that. If you say along the x-axis, it's the same as saying from the y-axis. It's the same. So along the stretching along the x-axis or dilating along the x-axis is the same as saying stretching or dilating from the y-axis. But guys, this factor is different. It's 1 on a. It's by a factor of 1 on a. Now, you got that? So where the a is next to the x, you don't say the scale factor's a. It's 1 on whatever a is. Okay? Now, okay, so if a is greater than 1, the graph is compressed. Now you're going to find this strange when I sketch it, but it's compressed from the y-axis or along the x-axis. So what is, I just want to show you something. But this only is relating to this type of function, not where the k is out the front. You can't use this, okay? So if this a is greater than 1, the graph is compressed from the y-axis or along the x-axis. It's compressed, okay? So it's the opposite way to the other one. If k was greater than 1, it was stretched in the other one. Okay, wait. And if a is a fraction between 0 and 1, the graph is stretched from the y-axis or along the x-axis. It's stretched. Okay? Now, the higher the value of a, the more the graph is compressed along the x-axis. So remember, when a is greater than 1, the graph is compressed along the x-axis or from the y-axis. Means it's getting closer to it. All right. Now let's have a look. If you look back at 15.2, it said that vertical dilations affect the y values. Doesn't that make sense? Vertical, y. Look at your axes. Y-axis, x-axis. So vertical dilations affect the y values. Horizontal dilations affect the x values of the function. All right. Horizontal, x. So we've already seen y equals function of negative x. It's a reflection in the y-axis. We've seen that before. We did that last year. Okay, you can consider that as a horizontal dilation with a scale factor of -1 if you want. Now we're going to look at these. Now this is where we've got to be very, very careful here. So I've got y equals x squared, and then I've got y equals 2x in brackets squared, which is like y equals 4x squared, isn't it? If I square the 2, what's 2x times 2x? 4x squared. That's really the graph of 4x squared. But I'm not going to talk about a stretch by a factor of 4. This is a stretch by a factor of 4 from the x-axis, but we don't talk about it that way. They don't want you to talk about it that way. They want you to talk about it as a stretch along the x-axis or from the y-axis. Okay? So we don't talk about it the same way as the other way. When your factor, all right, is next to the x in brackets, you don't talk about being stretched up and down. You have to tell me how it's stretched sideways. Okay? Now, have a look. Let's look at the rule. Y equals function of ax stretches the curve horizontally along the x-axis by a scale factor of 1 on a. So, when the a is next to the x, and in this case it is, we say that y equals x squared is stretched. I'll show you in a minute. We'll draw it in a minute. Horizontally or along the x-axis. Along the x-axis by a factor of what? Of 1 on 2. That's right. By a factor of 1/2. Now let's draw it. When x is 1, what do you get for y? No, when x is 1, what do I get? All right, 1, 4 up here. Wow. And -1's going to be 4 as well. So I've got, or I might just make it a bit smaller actually. I'm going to make, oh, that's okay. 1, 4, -1, 4. Now, this is what I want to talk about. All right, good. Okay, are we ready? Horizontal dilations affect the x values of the function. All right. What you've got to do here is, see how I've got the 0.24 on the original graph? It's now 1, 4. See what happened to the x value? It went from 2. So what I'm doing is I'm circling this value and I'm circling that value there, and I'm asking you to compare those two values. Horizontal dilations affect the x values of the function. What happened to this x value? This was 2, 4, and now it's 1, 4. The x value is half of what it was. Do you get it? I'm not talking about the y value. Look what happened to the y value. Stretches this way if you just want to look at this as y equals 4x squared, which we don't want to look at it as 4x squared, that was 1, 1, and now it's 1, 4. It's been stretched by a factor of 4 vertically, but only by it's been stretched by a factor of a half horizontally. So the thing is, when your thing is in brackets, you talk about how it's stretched horizontally. I don't want to know about vertically how it's stretched. See, it's stretched by a factor of a half horizontally, but it's actually stretched by a factor of 4 vertically. But we don't talk about vertically with this, only horizontally. All right? By a factor of a half from the y-axis. How can you tell? You look at the 2 points with the same y value, and it got narrower. It got narrower. So it's half as far away from the y-axis as what it used to be. Do you get it? So you could say compressed from the y-axis. See, if you're stretching by the factor of a half, it's actually being compressed. You know what? If you don't want to use the word compressed, just always use stretched, but just make sure you're using the correct axis. All right? Stretched by a factor of a half means it's actually compressed. All right? It's actually compressed from the y-axis or compressed along the x-axis. Okay? So it's actually being compressed, this one, from the y-axis or along the x-axis. Compressed from the y-axis or along the x-axis. If you're looking along the x-axis, it's actually being compressed. The original one was wider. Okay? Now, let's look at the next one. Y equals a half x squared. So the rule is, if y equals a to the x, it's stretched by a factor of 1 on a. So you might want to highlight that rule. This is so important. This is the rule. Just learn the rule. This is what you've got to know. It's where the a is next to the x. See, what happens is the opposite of what you think is going to happen. When the a is next to the x, it's the 1 on a. All right? When the constant's out the front, that's the scale factor. The scale factor here is 1 on a. It's because it's actually an inverse function. All right? Okay. So what's a in this case? Isn't a a half? Therefore, it's stretched along y-axis by a factor of 2. Along the y-axis by a factor of 2. Because it's 1 over a half, which is 2. Or along x-axis. Along x-axis from y-axis, sorry. So stretched along the x-axis by a factor of 2, or stretched from the y-axis by a factor of 2. Mistake, mistake, mistake. All right, choose some values. So if it's stretched along the x-axis by a factor of 2, this is the x-axis, it's getting wider. We know that's wider anyway. We know because that's y equals a quarter x squared. But you don't say that the factor's a quarter. All right? So give me a value. 1 is a half, isn't it? What's 2? What's when x is 2? What do you get? Yes. 1, 2, 1. Here we go. 2, 1. That would be -2, 1. And in the original one up here, we would have had -2, 4 and 2, 4. Okay, now, I want to put another value. All right, no, that's good. All right. How can you see this factor of 2? Where can you see it? What about when x is 4? What do you get when x is 4? Anyone? When x is 4, what's a half of 4? 2. 2 squared is 4. So we've got 4, 4. Put these others in. And -4, 4. Okay, this is the new graph. Why am I saying that it's stretched along the x-axis by a factor of 2? Where can you see it in the numbers? I've circled the greens and I've circled the reds. This was 1, 1. This is now 2, 1. See it? That's your factor of 2. This one, the red one up here was 2, 4, and now it's 4, 4. The x value is 2 times bigger. Do you see it? Stretched along the x-axis. That affects the x value. Can you see it now? Is it stretched by a factor of 2 from the y-axis? Because look, here, it's gotten wider from y. It's stretched by a factor of 2 from y. If you're going from y, you're actually going along x. You see? Sure. All right, now, combined transformations. The A is next to the x, but then we've got the sideways shift. So what we've got to do is we've got the same graph over here, but then the sideways shift. Okay? So it's going to look exactly like that, but now shift it 1 unit to the left. Because you say to yourself, what makes the x plus 1 equal to 0? It's negative 1. All right, so you've got to look at what's in the brackets. What makes that 0? X is negative 1 makes that 0. So everything, so this graph, so this is shifted now 1 unit left. So it's that graph shifted 1 unit left. Look at this. No, it's not. It's this one. Oh, I'm so sorry. Y equals, 2x squared. Shifted 1 unit left. There we go. See it? I should have done that one on. So they go together. All right. 1 unit left. No up and down. It's not shifted up and down. I'd have to put plus 1 on the end to be shifted up and down.
But to do it on 1 on A doesn't, it's just have to be right next to it.
It's this one. So guys, this is that shifted 1 unit left. Yes, it is. As if you're not sure. All right. Look, this is 2x squared. Yes, look at what's in the bracket. 2x squared. It is this graph shifted 1 unit left. Definitely. So, you give me some values. Tell me when x is negative 1. Just give me when x is negative 1. What do you get? When x is negative 1, isn't that 0? 2 times 0 is 0. 0 squared is 0. So that point here just got moved to there. All right. Now, here we've got 1, 4. Now substitute when x, if this is moved 1 left, shouldn't it be 0, 4? So let's have a look. When x is 0, what do you get? Y is 4. And you tell me now what this other value is without even substituting. Negative 2, 4. Okay, do you get it? So that, look, ignore this sideways shift to know which function it originally was. It was 2x squared. 2 bracket is x squared, but now there's an x plus 1 there, which just means sideways shift of 1 to the left. All right, sorry, I thought it was a half. Do you get it? So it's the top curve shifted 1 unit to the left. Yes?
What was a vertical stretch?
This is not a vertical stretch because the 2 is inside the bracket. So it's a horizontal stretch by a factor of a half.
But if it was, 2 not be squared.
Okay, so this is the same stretch as that, which is a factor of 1 on A. So this is what this is. This is the graph. Y equals x squared, stretched by a factor of a half along the x-axis, shifted 1 unit left. So I explain the 2 first because the 2 is inside the bracket of the function. It's a 1 on A stretch along the x-axis, and the x plus 1 tells me it's shifted 1 unit to the left. 1 transformation. See how the A is next to the x. So this is stretched by a factor of what? 3 or a third? A third. So if this is, so I'm going to draw this. You can just do a table of values. What's when x is 1? Y is 3. So when x is 1, y is 3. When x is -1, y will be 3. So I had, to be able to compare that, I would have had the point 3, here, and I would have had the point -3 there. Now you can see compressed. When I just draw the point 1, you can't compare it to that. But if I have 3 and 1, can you see it stretched by a factor of a third along the x-axis? Look, it was 3 and now it's 1, So compressed or stretched, you can put. It's actually been compressed along x-axis, but you can say stretched by a factor of a third. By factor of a third along x-axis. The fact that it's been stretched by a factor of a third means it's compressed. Wouldn't you say that's compressed? Along x. Along x means from y. It's been compressed from y. Yes. Do you get it now? Axis. The next one. What does A equal in this case? A is a third, but the factor that it's stretched by is 1 on A, which is 3. So the 3's right, but the A's not 3. The A is a third. So this factor, or the scale factor, the factor, is 1 on A, which is 1 on a third, which is 3. Because it's 1 on a third. Because A is a third. All right, so let's draw it. Do not do the point when x is 1. Do when x is 3. Because it comes out nice. When x is 3, what's y? Good. And -3, 1. Now let's see if this makes sense. This is the point 3, 1. That's -3, 1. So originally, so I'm going to circle these in. So what I'm doing with this one, I'm circling that and that. That explains. So in the first one, you can see the third there. See, 3, 1, 3. Here, to talk about now the scale factor is 3. It's been stretched by a factor of 3. Look, this is where you can see that 1, 1, 3, 1 affects the x value. Stretched. What am I going to say? Stretched along which axis? Along x-axis or from the y-axis by a factor of 3. Because by a factor of 1 on A. Guys? So see how this is 2 to the power of x and now this is 2 to the power of 2x? What's happened is the change is next to the x, not in front of the function. This is a horizontal dilation or stretch. All right, got it? And this is, what's the value of A in this one? The factor's 2, but the value of A is 1/2. Because it's AX. You have to know it as y equals the function of AX. So here the A is 2. This was the original function. Look what happened to the x. It's now 2x. Look what happened to the x here. It's x on 2, which is 1/2 x. The reason I'm writing it both ways is you can see it both ways. But when you do the 1 on A here, you do get 2. You get it? When you do the 1 on A here, you get 1/2. And that's the normal function. So let's sketch. Y equals 2 to the power of x. Table of values. in your head. When x is 0, y is, help me. When x is 1, y is, good. And you can do 2, 4 or whatever. So we've got 1, when x is 1, y is 2. And when x is 2, y is 4. And this just, you know, you've got your asymptote there. So this is y equals 2 to the power of x. 2 times 2 to the power of x. Take quick table of values in your head. When x is 0, what's y? When x is 0. 2 times 0 is 0. 2 to the 0 is 1. Tell me what this is supposed to do, by the way. It's supposed to stretch it along the x-axis by a factor of a half. Let's see. When x is 1, what do you get? Yeah, you do. 1, 4. Very good, and it is steeper. There we go, found it. I'm not doing the next point. Now, it says stretched, we think from our rule, stretched by a factor of a half from the x-axis. No, not from the x-axis, from the y-axis or along the x-axis. All right? The x1, horizontal, is along the x. Horizontal's along the x. So we're thinking stretched by a factor of a half, which is 1 on a, from the y-axis or along the x-axis. So how are you going to remember that? It's stretched horizontally. This is a horizontal. And it is, look. 2, 4 became 1, 4. See, if I'm talking about it stretching along x, I need the y values to be the same. It's like your independent, you know, your variable. The x is changing. So make sure the y's are the same if you want to tell me that x is changing. You can't have y changing and x changing. It's not, something's got to be constant, and the other one, you'll see the other one change. Now this one, we're thinking stretched by a factor of what? A is a half this time, so stretched by a factor of 2, because it's 1 on a half. 2, which happens to be 1 over a half, from the y-axis or along the x-axis. So without doing a table of values, you tell me this point 2, 4 is now going to be what? Just what would 2, 4 now be if it's stretched by a factor of 2? It should be 4, 4. And 1, 2 should now be 2, 2. Let's have a look. Table of values. When x is 0, we get 1. When x is, I wouldn't choose when x is 1. You really want to be doing 2 to the half. When x is 2, y is 2. Good. So we've got 2, 2. And when x is 4, what do you get? 4, 4. Lovely. Now let's see how this is stretched by a factor of 2 along the x-axis or from the y-axis. I'm going to circle. 1, 2 became 2, 2. The x value got 2 times bigger. You see it? And I can do 2, 4 became 4, 4. The x value got 2 times bigger. There's your factor of 2 from the x, from the y-axis along the x-axis. Ax, you know, this is your x, like it's next to it. Let's just do a table of values here. All right. All right, let's just, what does 1 on x look like? Isn't it a, yeah, I should have had a bit more room here. Looks like this. Oh dear. 1, 1. And for example, this might be when x is 3. What about, yeah, we'll just leave it. 1, 1. And the other one's here, right? What are you going to do? Which value do you want to choose? I'd choose when x is a third. I don't want to choose when x is 3. Oh, all right. No, you can do when x is 1. What do you get? So 1, 1. What is it when x is 1 now? Y is a, all right, 1 1/3. All right, what else? Choose another nice value. What about when x is 1/3? What's y? No. When x itself is 1/3, what's 3 times 1/3? So it's 1 on 1 is 1. So when x is 1/3, it's 1. All right, there we go. When x is I should have done it in green or red. So when x is 1/3, just be careful here. Y is 1. When x is 1, y is 1/3. It looks like this. I know this is a bit of a hard one. I'm not going to put values on the other one. Now, don't we say, all right, have you found 2 points with the same y value? Yes? I'll show you what this first function means. You know how you've got to write it as y equals ax? There's your ax. So it is a factor of 1/3. You can see it here. Look. You know how you find 2 y values that are the same? 1, 1, 1/3 1. Because the 3, if you do it the other way, if you put the 3rd out the front, you're doing it the other way. So we don't, you just keep it like that. That is your ax. So it's 1 on a. 1 on a in this case is 1/3. So it's stretched by a factor of 1/3 along the x-axis. Didn't it get, look, 1, 1 became 1/3 1. The x value is 1/3 of what it was.
It makes more sense if you put the denominator
You,
in brackets.
yes, you very good. You have to put that denominator in brackets. Otherwise, if you pull 1/3 out the front, that becomes k times the function of x. It's different.
It's just the factor.
Yeah, so you don't do it like that. You don't put, this is a horizontal dilation because we're better off putting the a in the bracket. All right? So we say stretched by a factor of 1/3 along the x-axis or from the y-axis. Now, I know that if you are tempted to really put this bracket around the 3x, if you want to put the 3rd separate, you've got to be talking about stretching from the y, from the x-axis along the y if we want to do it the other way. If I put that 3rd out the front and wrote it as 1/3 times 1 on x, I'd have to talk about it being stretched up and down, not sideways. Do you get it? This is a confusing one because you could go either way. But by putting this in brackets, you're talking stretched horizontally.